Okay, binomial theorem lets us expand x plus y to the 5th power, x plus y to the 50th power, or x plus y to the 100th power, or x plus y to any random power n. So let me state the binomial theorem, and it looks like this. Okay, x plus y to the nth power. We'll start out with x to the n plus. Then you have x will be down or decrease by a power, means n minus 1, and y will be the first power. I'm going to do all my x's and y's first, and I'm going to show you how to get the coefficients. And then x will go down by another, so it'll be n minus 2, and then y will have a power of 2 plus. And then x now will be n minus 3, and y will be to the 3. And let's do one more, and then we'll use dot dot dot, and then x will be to n minus 1 because n minus 4 because I'm going down by 1, and then y becomes 4th power. So when I add these two, it will become n. And when I add these two powers, it will become n. So I always have to add up to whatever the power is, n. And then you're going to have plus dot dot dot, and some random term is going to be x to the n minus r. We'll use r now, and then y to the r. And then plus dot dot dot, keep going, and the last term is going to be y to the n. And we start out with x to the n, we end with y to the n. Now, the only thing that's left missing is what do I put in front of this right here? Okay, what are my coefficients? Now, we could use Pascal's triangle to get those numbers, but we can also use factorials. Okay, this becomes n factorial, all that over. The factorials on the bottom come directly from these exponents. So it'd be n minus 1 factorial times 1 factorial. And then this term in the second, and then the next one will be n factorial. Top will always be n factorial. N minus 2 factorial times 2 factorial. And then the next one will have a coefficient of n factorial, all that over n minus 3 factorial times 3 factorial. And then next one will be, again, n factorial on the top. In the bottom, I'm going to have n minus 4 factorial times 4 factorial. And then some random term over here will be n factorial, all that over n minus r factorial times r factorial. Okay, so that's it. That's the binomial theorem. So if you want to, let me do a couple of examples. Let's say we want to expand, let's say 2x plus 3y, and let's say we want to expand this to 8th power. Alright, let's do this problem here. Okay, and this problem, I'm going to have 2x to the 8th plus, and let's write this in factorial notation. I'm going to get 8 factorial over, this will be 1 factorial times 7 factorial. So x is to the 7th and y is not x. Okay, got to be careful. This is not x, this is really 2x. And I got to put that in parentheses. And then 3y will be to the first power plus. Okay, then I have 8 factorial, all that over 2 factorial times 6 factorial. Then my 2x is to the 6th, and then my 3y is to the 2nd, and then plus. Okay, 8 factorial, all that over 3 factorial times 5 factorial. My 2x is to the 5th, and my 3y is to the 3rd. And I keep going. I get 8 factorial, all that over. Now I have a 4 factorial. Okay, and then that will be 4 factorial again. and then 2x will be to the fourth, and my 3y is to the fourth. Plus, okay, I have 8 factorial, all that over 5 factorial times 3 factorial, and then I have 2x is to the third because my x term is going down, and then my 3y is going to be to the fifth because my y term comes up, plus 8 factorial, all that over 6 factorial times 2 factorial, and then I have a 2x is now to the second, and then I have a 3y is to the sixth. Remember, all the powers are adding up to 8 in this particular problem. So then I have next term is going to be 8 factorial, all that over 7 factorial times 1 factorial, and then my 2x is to the first power, and then I have a 3y is to the 7th power, and then the last one. Okay, I can write the factorial. It would be 8 factorial, 8 factorial, okay, times 0 factorial, but I don't need to. My last term is going to be 3y is to the 8th. Okay, and that's it. And what happens if I didn't have a plus in the middle? If this is a minus, no big deal. Okay, you can either put a negative inside the 3y. That's one way of writing it. Okay, and that'll take care of everything. Okay, every place you see a 3y, put a negative in there. Or if you choose not to put a negative there, and let's do it without doing that way, there is a second option, and that option is that we know the sign changes. So the first one's plus, and then the second one is going to be negative. Next one's going to be plus, and the next one after that is going to be negative. Okay, and then next one's going to be plus, and the one after that will be negative. And then plus, and then one after that will be negative. And then plus. So they alternate. Okay, first term is plus, second term is negative, third term is plus, okay, fourth term is negative, so on and so forth. So you can do it that way also. So either way, you can handle the negative. Alright, it's going to be a short lesson. So one more thing is, what if I, gave you something like 2, this is what shows up on SAT, 2x plus 3y to the 1,000th power. Okay, now, of course, even with the binomial theorem, it's going to take a long time for you to do that. So how do they check if you can actually do binomial theorem? Is they'll ask you to find, let's say, 501st term. Okay, 501st term. So one thing we do know about 501st term, the 3y will have a power of 500. Okay, let's do 502nd term. Okay, I'm going to change my mind because I don't want to. Okay, 502nd term. Okay, so that means my 3y, okay, will have 501st power, because wherever the term is, the power here will be 1 less. And I also know my 2x, okay, will have a power, so when I add this number, it has to add up to 1,000. That means 499 power. Okay, what about my coefficient? That's easy. Get a 1,000 factorial on the top, because I'm raising to 1,000 power. In the bottom, I get these two numbers right there, which is 499 factorial times 501 factorial. And that is the 502nd term of this binomial expansion. But what happens if you have a negative? Okay, let's change that to a negative. Let's see what happens. When you have a negative, it's easy. Just put a negative right there, and everything else will take care of it. Of course, this whole thing will end up being negative, because when you raise a negative to an odd power, you're going to end up getting a negative sign in the front. Okay, and you don't have to simplify. You're done. Leave it in factorial notation, even for binomial expansions. Okay, so that's basically it. Okay, we can find any particular term of a binomial expansion by doing this. Okay. Now, one thing we need to talk about, the last thing is this. Okay, that when you have n factorial over r factorial times n minus r factorial, which is really the coefficient in the binomial theorem, you can, in your calculator, there's always a button. It's called NCR. N choose R. That means you are picking this many numbers out of total that many numbers. For example, in the lottery tonight, Mega Ball, okay, we have 75 numbers, and we're going to pick 5 out of the 75. Sometimes it's written like that. This really means, okay, 75 factorial, all that over 5 factorial, and then 75 minus 5 factorial, which is really 75 factorial over 5 factorial times 70 factorial. Or, in your calculator, it will be 75 choose 5. Let's figure that out using a calculator. So when you go to your handy dandy calculator here, okay, you're going to turn it on, and you're going to go to probability, if you have a graphing calculator, okay, and then probability. I think your scientific calculators will have this also, so I'll show you that button tomorrow in class. You got NCR, you see that, and you punch in 75, and then you're going to punch in a comma, and then you're going to punch in 5, okay, and then you're going to hit enter. So what this tells us is how many different ways can you arrange, okay, can you pick 5 numbers out of 75 numbers. That turns out to be 17,259,390. Okay, so 1 out of 17,259,000, what was that again? 390. That is the probability of picking 5 numbers out of 17. But we also have mega number. Okay, mega number, there's 15 you got to pick from. So what's the probability of picking 1 out of 15? That'll be times 1 out of 15. So when you multiply this out, okay, this will give us a probability of me winning the lottery. So we're going to multiply that by 15. Okay, so the probability of me winning the lottery tonight turns out to be 1 out of 258 million. Okay, let me clear that. Okay, 1 out of 258 million. Okay, 890,850. Okay, 890,850. Okay, that is my probability of winning the lottery tonight. Okay, and the Mega Million. Okay, now, well, if you don't play, the probability is 0. If you have at least 1 ticket, the probability is that. Okay, so is it worth it? Well, likelihood of me getting hit by lightning is 1 out of 225,000. Okay, so there's a better chance of me get hit by lightning when it rains on Thursday, okay, than me winning the lottery tomorrow or tonight. So that's it. That's the NCR button. Okay, you can calculate any of the factorials by using NCR. So if you go 10 factorial over, let's say, 2 factorial times 8 factorial, you would type in your calculator as 10. Okay, then choose 2. That will give you the value. Okay.